Hello!
Hey, boys and girls, it's Mrs. Alter
And Mrs. Curl.
Welcome back, and we are excited to talk to you today about benchmark and equivalent fractions.
Yes, I love fractions, Mrs. Alter. I always say fractions are our friends.
They are. They're so cute and little, and people just get scared of them. All right, so we know that fractions are comparing a part to a whole. And what operation do you think of, Miss Curl, when you see a fraction?
Every time I see a fraction, I think of division.
Okay.
We are dividing. And that's why fractions aren't scary, because we all know how to divide. And that's all they are, is showing division. And it's that part to whole. A piece to the whole.
Right, or the part to the total.
Yes, or
Okay.
total.
So let's take a look at your class. If you have 24 students in your class, 24 would be talking about the what? The part of the whole.
The whole. That's my total number of students in my class.
Okay.
And let's say we were talking about ice cream flavors.
Ooh, I love chocolate mint chip.
So if I had 16 out of my 24 that liked mint chocolate chip, where would that 16 go?
That would be your numerator, or the part.
Or the part.
Okay. Okay, so we have 16 who like, I'm just going to put mint ice cream out of...
A total number of students in
All
the
right, so
classroom.
total students. My writing's getting a little crazy here.
It'll work.
All right, so again, that part to whole relationship.
Definitely.
All right. And we know that we can write equivalent fractions. We can simplify fractions, which we talked about the other day, which we could simplify this. And we have equivalent fractions. All right, so go ahead and pause the video and copy that down.
And as we can see, equivalent fractions mean we're going to multiply the numerator and the denominator by the same number. So just like Ms. Alter just said, it's just like when we simplified fractions. It's two fractions that represent the same thing. When we simplify, we take a large fraction and make it smaller.
Right. We're dividing the numerator and denominator by the same number. Now we're multiplying the numerator and denominator by the same number.
So if we just think of one that we already know, like Ms. Alter, if I had 1/2, and I wanted to think of an equivalent fraction to 1/2, that is one part out of my total of two parts. Another equivalent fraction would be 2/4.
Right.
And I know that 2/4 and 1/2 are the same thing, and that is what equivalent mean. Equivalent means equal. So 1/2 and 2/4 are equal.
All right. So let's look at some examples. So the first one, we're going to write an equivalent fraction for 7/24.
Okay. So if I have 7/24, I always work smarter, not harder. So I'm going to multiply by 2. Let's start with something that's easy.
So 7 times 2 gives me what?
14
And 24 times 2?
gives me 48.
So you're using that same factor to multiply your numerator and denominator.
Miss Alter?
Yes.
And 24 times 2, we said.
Is 48.
So the equivalent fractions here, 14 out of 48. So 14/48 is the same fraction. They represent the same parts as 7 out of 24.
Right. And if we did it in reverse, if we simplified, 14 divided by 2 is 7, 48 divided by 2 is 24.
Right. So equivalent fractions can go either way.
Yep. Okay, so now we're going to make one more. So you could take 14 over 48 and multiply those two by the same factor. Or let's go back to 7 over 24. I like what Miss Curl says, work smarter, not harder.
Right. So this time let's just multiply times 3.
Okay.
And let's try 3.
I'll just take that next factor.
So 24 times 3 is going to give me that 72. And I can do 7 times 3. And that is 21.
My writing's getting a little crazy, guys. Sorry.
So again, I've made another equivalent fraction. 21 over 72 is equivalent, is the same as, that's what equivalent means, that equal as 7/24.
The same part to whole relationship.
Those relationships are the same.
Okay. So then another example, we have 2/3. So what are we going to do with 2/3?
Well, let's do 2 again. Let's do an easy first. So if I multiply, the top and the bottom by 2, so that's going to give me 4/6.
Okay. And let's do one more.
Let's do a crazy one. Let's do 180.
We're getting out of control here.
Out of control. So if I multiply that top, 2 times 180, that gives me 360. And I can do the bottom, 3 times 180, and that gives me 540. So again,
big numbers.
Yes, but look, it's the same thing. It doesn't matter what I choose to multiply by. 360 over 540 is equivalent to 2/3. If I simplified that down, it's going to give me 2/3. Yep. If I multiply that, it's going to give me 2/3.
So if all of these fractions simplified to the same lowest numerator and denominator, then they're equivalent.
That's right.
All right. So we have some you try it. All right. So go ahead and pause the video, copy 5/8 and 5/6 down. We want you to write 2 equivalent fractions for each of those.
Now, is everybody going to have the same answer for this, Mrs. Alter?
No.
There are 100 different, million,
You could go crazy like Miss Curl and pick a large number, or you could just work smarter and use those simple numbers.
All right. So let's look at some examples that we came up with. Now, yours might not look like ours, but the first one we multiplied each, the numerator and denominator by what, Mrs. Alter?
We multiplied them by 2 to get 10/16, and then we multiplied the numerator and denominator by 4 to get 20 32nds.
Now, Miss Alter likes to draw the little rainbows, and that's great if you like the rainbows, if that helps you, but you don't have to draw those rainbows if you don't need them, if you can just remember what you're multiplying by.
It just helps me keep my work organized.
Which is nice to see. All right, and on that second one, we chose 2 again.
Okay, so you have 10/12, and then we chose another easy one. Multiplying by 10, really, you're just putting that 0 behind it and moving that decimal at the place value.
And I will tell y'all that if I have to find equivalent fractions, I always use 2, 10, 100, 1,000, those easy ones, because that's easier to find if it's just asking those type of questions.
All right, so now we're going to talk about benchmark fractions. These are those fractions that you know, like 1/2. What are some other benchmark fractions?
1/3 when we break a whole into thirds, or we break a whole into fourths. So let's look at these first 3. So our first one we want to talk about is 1/2.
So we know that's talking about 1 part out of 2 total.
So I can look at that as a...
So here we have 1 part out of 2 total.
Okay,
so this is a half and this is a half.
We have some more we want to show you. So here's our whole. We're
crazy
throwing
here.
some crazy stuff around, and there's 1/2 and 1/2.
I like this setup because if you're thinking about it on a number line, then this is 1 whole. So your halfway mark would be right there, and 0 would be down here to the left. Oh, it is. Wow, that's time for us to go.
Yeah, we'll pause it right there.
Please.
Oops. So sorry about that.
All right, so we're back.
We're back.
Okay, so again, here's 0 if you're on a number line. Your halfway, sorry guys, your halfway mark and your 1 whole mark. All right, and Miss Curl's going to throw something our way.
Yeah, I'm going to throw some thirds. Let's talk about thirds. So again, we can show you the circle graph. We might have to push that up a little bit.
And again, our denominator tells us how many pieces of the pie make a total.
Right, and we're looking at thirds, so I have 3
1/3,
pieces.
2/3, and 3/3 make up that 1 whole.
Because 3 over 3 is 1. And again, we're going to show this on the
Number line
or number line or fraction pieces. Yes. So again, we can fit that in.
And then we have our...
Oh, hold on, I'm pulling them out here. I have our fourths, so we can show fourths.
So 4 pieces, 4 out of 4 make up that 1 whole.
And I like because these are kind of numbered, so you can see that if I take 1/4 and 1/4, that's 2/4, which is the same as half, which we talked about those equivalent fractions. We can see that 2/4 is the same as 1/2. Okay. All right. And we have some other, let's just kind of slide these.
Get our area clean here,
Yeah, let's slide that off and slide that off. And we're not going to show all these different fraction pieces anymore, but we talked about our, that those are benchmarks. These are fractions that we need to know. And so I know you guys have already copied those down.
Okay, and if we're looking again, if we have our number line, and we have 0 and 1 whole, okay, we know that we're going to break it up into 2 equal parts, so that halfway mark, so there's your 1/2 mark, okay, and then with our thirds, again, it's going to be that same distance between 1 and 0, except now, how many pieces are we going to break it up into?
3, because that is my total. I'm going to break it into 3 pieces. And a lot of times you're asked to put things on a number line. And if you'll remember to look at your denominator, that tells you how many pieces you're breaking it into.
Or how many sections. So
Sections.
1, 2, 3 sections.
And 1, 2. And guess we're going to make 4 sections when we have a 4th.
So there's our half. So we have 1/4, 2/4, which is a half, and 3/4. And then 4/4 again brings us back to our 1 whole. Okay, and then another set of benchmark fractions. You know your fifths, and you know your eighths. Okay.
And again, so I can look at these, and 3/5 means 3 parts out of 5
total.
whole. Or if I'm looking at eighths, I know 4/8 is again that equivalent fraction to 1/2.
This makes me think of pizza.
It does.
So
yes.
I know that my kids, they can eat 3 out of 8 or 4 out of 8 pizzas because they're growing.
And do we want to add the whole on there to these, Miss Alter? So we have,
Sure.
yeah, let's add, because I like to see where we know that we have that final total, which is 5 out of 5, which is 1.
And going back to what we said about fractions being division, 5 divided by 5 is that 1 whole, or that 1 whole piece.
And the same thing here. 4 divided by 8 is 1/2.
1/2.
And that is why that fractions are just division. And we did another beginning of an example there, 1/10, 2/10, and 3/10. So again, you can use any denominator and break it into all of its pieces. All right, so let's look over at some fraction benchmark rules. So pause the video. We wanted to show that. Yeah, pause the video right there and get that copied down. All right, so we can go ahead. Go ahead. I'm sorry.
When we have fractions that are close to 0, they have a smaller numerator and a much larger denominator. So I know that 1/8, because the numerator is smaller than the denominator and a larger denominator, this is going to be closer to 0 on the number line. Same with 2/15. My numerator is small, my denominator is large, so it's going to be a small. Think of it as 2 slices out of 15 slices total. That's going to be not very large. And 3 out of 20. So those are going to be closer to 0. Okay. Go ahead and pause again. Copy those down.
Now these are going to be fractions that are close to half. So that means the numerator is about half of the denominator. So again, if I have 50 out of 100, half of 100 is 50, so that is about half of that.
And we did these first few. These are going to simplify to 1/2. So they're
Right.
actually on the half
Perfect.
mark. Okay. Now here, if I take 17, what's half of $17, Miss Carl?
Well, gosh, half of $17 would be 8.5.
Okay. So 8 is just a little bit smaller than that. So this is going to be just a little bit to the left of 1/2. It's close to it.
Very close. Right? And that's what we're looking for. This is, like we said, those benchmarks. This is just helping us know where our fraction is falling. Is it closer to 0? Is it closer to half? Or is it closer to 1?
And using that same example, 8.5 is half of 17. So 9/17 would just be a little bit to the right of that 1/2 mark on a number line.
Absolutely. Same thing with the 11, because 11 doesn't divide out evenly. So about 5.5. So 5, that's going to make that 5/11 close to a half, or 6/11 is going to be really close to half.
Okay.
All right, and our last one is, again, we are going back. We can have it close to 0, have it close to half, or have it close to 1.
So go ahead and push pause and copy this down.
So these are going to be close to 1.
Right, with that larger numerator closer to the denominator size. Okay, so 7/8, well, I know that 8/8 is 1 whole, so that's going to be really close to 1 whole. And I know that 3/4, that's between 1/2 and 1 whole.
And it's close to that. So again, you'll see, like, you want to compare. We're comparing our numerator to our denominator. This also helps when we start ordering our fractions. We want to think about where these fractions fall and how they relate to each other.
Right.
All right, so we have some practice problems for you to try. And you are going to tell whether these fractions are closer to 0, half, or 1. So copy these 3 down. Number 1 is
6/7.
number 2.
7/78.
And number 3,
22/45.
okay, please copy these problems down and then tell us, are they closer to